Hello and welcome to today's stream. So today I worked on an idea I had in my mind for the last couple of weeks or maybe even months. And this is about testing and about decoupling the test code from the implementation code mainly. So basically this concept is the most important part about this, but in today's stream we will see how we can do this with Cypress and also mock service worker for mocking. But yeah, as I said, it's mainly about the concept. It's mostly about, well, the most important part of this idea is the decoupling from the test code, from the implementation code. So I've set up a little demo project, so let's check this out. So the first step will be to look at the directory structure and which tools we use, as I said, Cypress, but also Vite and Vue. But let's see how this looks. Okay, so with Cypress, by default, we have this Cypress configuration file. I think there's nothing too special in it, although I've set it up so that, first of all our test files or our specification files are located in the test specifications directory by default. So there's a little change from the default Cypress config. And it's also prepared for component tests. So we could also use Cypress to test our Vue components directly, but that's not the scope of today's stream, but it would be possible too. And yeah, apart from that, we also see the settings for the Cypress watch mode, but more about the watch mode later. Okay, other than that, it's like I said, it's a Vite project, so Vite is super fast dev environment, can highly recommend it. And yeah, let's check out all the dependencies we've installed. So for this project, we use Vue mainly, and other than that, a lot of boilerplate stuff like linting, config, and so on, and so on. But yeah, most important part is Cypress for the topic of the stream. Like I said, the setup is prepared to also test Vue components standalone in standalone mode, but yeah, more about that maybe in a later stream. So really important is only Cypress, the Cypress dependency, the Cypress watch and reload dependency, the mock service worker dependency. So maybe let's check out the mock service worker real quick. So mock service worker is a really cool project that we can use to, instead of mocking our services directly, for example, like in Vue component unit tests, we maybe would mock our services or some methods that make API requests. But with mock service worker, we can leave our code like it is, so we don't have to mock any functions, but we mock the API layer directly. And the cool thing about that is that we can use this in unit tests, but also we can use this when we write our end-to-end test with Cypress. Okay, maybe in this little example you can see what this is all about. So we can say we have a REST request, a POST request, and this POST request is for a specific route, for example, and then we can intercept the request, the POST request to this route, and mock the response basically. So in this case, we would mock the login request, and the response of this mocked login request returns some data. And this is very useful for testing, obviously. Okay, so let's go ahead. We already saw the Cypress config, nothing too special in it. Other than that, it's not really a lot of dot files, you know that. But next interesting part is the test directory. And in the test directory, we have modules, specifications, and utils. And in the modules directory, the idea is that in the modules directory, we have all the different parts of our application, or the test helper functions for different types of content or different sections of our application. In this case, like imagine we have an application for writing articles, blog articles, for example, but this could be anything. And then in here, we have a module for all the test helper code for this article. And then we could have a module for all the user stuff. Then there would be a user directory as well, with again all the helper functions to test the user functionality. Then we have the specifications directory, and inside the specifications directory, this is where our tests are located. So we will take a closer look at this in the next step, but for now, specifications is the directory with all the test files. And then we have some utils, and those utility functions are the ones for the mock service worker stuff. And we also have preconditions, but we will see what preconditions are later. So this is our test directory. In the source directory, this is a typical Vue application. We have this main file, then some TypeScript specific stuff. That's not really important right now. And then just a regular components directory. So like you used from a plain old Vue app. But this is Vue 3, just to make this clear. And other than that, we also have the Cypress directory, and in the Cypress directory, again, nothing special in here. Only interesting thing here is that this that we use the Vite dev server in here, but this is only for components testing, so that's not what we are using in this stream. Other than that, there's nothing special in here, like support and fixtures, they're basically empty. This is the default file, and in here there's some stuff for the watch and reload plugin, but more of that later. Okay, that was the basic directory structure of this project. And before I proceed, I want to let you know, if you have any questions, please just go ahead and ask them in chat. So I always have an eye on the chat. So if you want to know anything about a specific functionality, just ask in the chat. Okay, so this was the basic setup. Let's go ahead and take a look at the simple demo application we are going to test today. And it's really a very, very simple demo application, just for the sake of testing it, so that I can demonstrate the basic concepts that I want to show you. So this is just a simple form, and if we press submit and the API request fails, we see an error, and if the API request goes through, then we see a success. And this is what we want to test today. So very simple demo application. Let's take a closer look. Here in the app component, we can see we have some form fields, like this input for the title field, then a text area field for the body field, as we can see here, the success and error message, and last but not least, the submit button. And you might have noticed already, all of those elements use data QA tags. So we can later use those data QA tags to target those elements in our test code. There are other approaches how you could do this. So like there is the testing library. Let's take a quick look at that. So this testing library is originally by Kenzie Dots, and here is the navigation. Okay. And Kenzie Dots says that we shouldn't use like such data QA selectors, or especially not CSS selectors or anything like that, but we should let's take a closer look. I have to make this bigger so I can see the navigation here. Let's take a look at some examples. Yeah, he says we should use find by text, for example, or find by role instead of CSS selectors or like data QA selectors or anything like that. And the logic is that your tests are even more useful if you use something like find by text, because then you also test that the correct text is in place, and you test it really like a user uses your application, like a user would describe how they navigate through an application. So like a user would say, I type something in the like username input, so you could select by the name attribute, for example, and then I expect to see the text user successfully created, for example. So that is the reason why some, or especially Kenzie Dots, argues that we should use selectors like find by role or find by text. But I'm not 100% convinced, because like it makes it really, really complicated when you do stuff like internalization, for example. So you maybe don't have, or I build mainly German applications, and then I would have German strings in my English test code and so on. And yeah, I'm not 100% convinced. So I think using data QA text is fine as well. And it serves the purpose of not being dependent on some CSS selectors, for example, and also making clear to the developers that they are not supposed to simply delete like a data QA selector. At least they should expect that the tests break when they change something here. Okay, so let's see if there is anything special here. Yeah, we are using the composition API to get out the form data. Oh, let's rename this real quick. Yeah, we're using the composition API for the title and the body field. The values are stored here. Then we have this submit method, and this submit method uses fetch, and it fetches this API endpoint and sends the title and the body of the article. And if there is OK response code, we set the status to success, and otherwise we set it to an error. So that's it for the simple demo application that we want to test. So let's talk about the main part. The main part is the decoupling of our test code from the implementation of our application. And the first part of this is using preconditions. So let's take a look at a precondition. We have them inside of our test directory, and then in the module, in the article module, for example, we have this precondition file. And in this precondition file, we have, for now, we have two preconditions. The first one is user can create new article. This means if we want to test, if we want to write a test that's about creating a new article, then we need this precondition, which says, which prepares everything necessary so that a user can create a new article. And in here, for this application, we use, like I said, the mock service worker for mocking the network layer. But the idea is that we could, inside of such a precondition, we could do anything. So basically, we could also mock a database, for example. So we could seed data in a database, or yeah, we can create a JSON file that's served by some API, anything. So doesn't matter how our application works behind the scenes. Just important that everything in user can create a new article. Everything is set up so that the test for creating a new article can succeed. And this can mean that we mock the API request, or it can mean that we see the database, or it can basically mean anything. Okay, and in here we see how we use the mock service worker. This might look a little hacky, but this is necessary so we can make our preconditions work with Cypress and also in the browser. We will see this later. Because by default, it's not so easy to use mock service worker with Cypress, because Cypress runs basically the Cypress JavaScript instance runs in a different context than our application runs. But to make the mock service worker functionality work, we must run it in the same context. And we can do this by injecting the mock service worker here, but more about that later. Okay, so here the user can create new article, precondition. We intercept the /API/articles endpoint. We saw that in our application, that we fetch exactly this endpoint. And we respond with some data. And we can change this data when we call our precondition, but by default, we just use some default data that we can see above. So this is our first precondition, and then we also have a precondition for user cannot create new article. This means that something goes wrong when creating a new article. And in this case, this means when sending a post request to /API/articles, then we respond with 500 status code, so with an error, basically. Okay, those are our two preconditions for this demo, but in a real world application, you would have a lot of preconditions, like, for example, a precondition user is logged in, for example, to fake a logged in user. Or user has 3 articles, for example, so you can write a test with for showing a list of the 3 latest articles of a user, stuff like that. So you can create a lot of those preconditions, and then you can use those preconditions in your tests, but not only in your tests, but also during development. So that's also a very interesting aspect of mock service worker, that you can set it up in a way that you can use it as a tool for development. So in our main file, so the main file is where we create where we mount our Vue app. In this main file, I've created a prepare function. And this prepare function, this is skipped, or this prepare function only does stuff when the current environment is not production. So only in test mode and in development mode, or any other mode other than production, we run this code here. And in here, first of all, we start our mock service worker server, let's take a quick look at this one. So we have this browser file. Browser means this is the mock service worker implementation for the browser, because when we want to write unit tests, then we need mock service worker code that is meant to be run on the backend, so in a Node.js context, and this is meant to run in a browser context. That's why it's named browser. And in here, we simply set up a new worker, a new mock service worker, and this worker then intercepts, or is able to intercept, all of our fetch and in general network requests. And here we export the server that we are using in the main file that we saw before. And because we are already here, we can see here this __ mock service worker global variable that's created here. And like I already hinted before, we use this in Cypress then to have access to the REST and server methods or objects of mock service worker. But yeah, we will come to that. For now, in main.ts, we see that we import the server from our mock service worker browser file, and we start the server in here. And then here I prepared some lines to enable preconditions if we need them. And in this case, I enabled the user can create new article precondition. So just to be sure, I comment this out again. And let's press submit here. So I press submit. And after pressing submit, we see an error because the fetch request fails, because there is no API running. And that's why we get a 404 when pressing submit here. But with mock service worker enabled and also enabling our precondition, as our user can create new article precondition, when I reload this, and we can see here that mocking is enabled from the mock service worker. And now when pressing submit, we can see the success message, because now we can also see it here. The mock service worker takes over and intercepts the /API/articles request, and everything works as it would work when we would use a regular API endpoint. We even see the network request. And that's one advantage of mock service worker, because there are some other solutions that are able to intercept network requests in JavaScript. But as far as I know, they all work by either overriding fetch or overriding the XML HTTP request object. And mock service worker does, what mock service worker does is that it installs a service worker, like the name suggests, and this service worker is responsible for intercepting the network requests. And I think this is a really smart way to do this. And so when working as a developer, when working with this, it all looks exactly like it would look when using a real API. Or almost, at least, because one difference we can see here, we can see that this request is intercepted by the service worker, but that's not really important for working with it. Okay, so we can see we can use preconditions also in development mode, and this can be really useful. For example, if you if development of the backend and the front end is separated from each other, then maybe the front end might be faster in implementing some functionality, some new functionality, and with this mocking approach, they can do this even before there exists a real API endpoint for the new feature that you are building. So that's really, really useful. And the idea is that you can add those preconditions in here and comment those out that you don't need and enable those that you need for working on the current feature. And the build tools are smart enough to not bundle all this code, because when you build for a production, the build tool will know that this code can never be reached, because when node n equals production, then this code can never be reached, and the build tools are smart enough to just remove this part of the code. At least the most common build tools like Webpack and Rollup and so on. Okay, so let's comment this out real quick and take a closer look at how we handle preconditions in Cypress, because what we saw now is how we can use preconditions for development, but the main purpose is to use them for testing in Cypress. So the most important part for using preconditions with Cypress is this prepare method. We can see here in the util functions for our preconditions, we have this prepare function. And this prepare function takes a precondition, so a function like precondition, like something like this function, for example, user can create new article, and an optional payload. And the payload, if we want to override the data that is used when mocking the API response, then we can do this with the payload. But by default, what we are doing in this prepare function is to inject the global mock service worker variable that we saw in, where did we see it? In the browser file. So here we initialize the global mock service worker function. And then we can, with Cypress window, we get access to the window object of the page under test. So this is what I meant before. Cypress code runs in a different context than the application, but by using Cypress window, we get access to the window object of the application context. And in the window object of the application context has this mock service worker global variable. If not, then we throw an error. Then it basically means that the page is not loaded yet, most likely. And then we run the precondition with the given payload, if there is any, and also the mock service worker instance. So when we take a look again, then we can see here, this is the mock service worker param, and this object has a server and rest. So, okay. This might seem a little complicated, but yeah, like I said, it is necessary to make mock service worker run in the same context as the application. Okay, then we can see how we use this in a real test. So let me check my README real quick. So this was it about preconditions and basically also about mock service worker. And the next part is probably the most interesting part. This is the DSL part. So DSL means domain specific language, and the idea is that we create a domain specific language that we can use to write our tests. And this is where the deep coupling of the test code and the implementation happens. So the first step is that the first step of decoupling happens through the preconditions, because thanks to the preconditions here in our test code. So here we see the test code for it should create a new article. So basically the happy path for creating an article. And in our test code, here we use the precondition instead of directly specifying the mock here. It's like typically let's take a look at the Cypress documentation real quick. So let's make this bigger again and go to the documentation. And how is it called? I think the sub requests. Yeah. So out of the box, we can use Cypress to intercept requests. So if you are familiar with Cypress, you might wonder, why does he use this mock service worker? Because Cypress can do this out of the box. But we can Cypress intercept can only be used in the Cypress context. And the nice thing about mock service worker is that we can use it during development, and we can use it for unit tests, and we can use it in Cypress as well. So while Cyp intercept can only be used in Cypress, mock service worker can be used everywhere. That's why I want to use mock service worker. Okay, but to get back to what I wanted to say, like usually you might do something like that. You should create new article test, and then you would say Cypress intercept post request for API articles, for example, and then some stuff like that. But by doing that, our test code now knows about a very important implementation detail, and that is that we're making a request to some API. Like, yeah, this is probably one of the most important implementation details even, and the idea of this decoupling is that the test does not know anything about any implementation detail. And if we do it like this, then the test would know about a very, very important implementation detail. And when we remove this, now our test does not know anything about any implementation detail. Just make sure that we prepare the user can create new article precondition. But like I said before, in this precondition, we could seed a database, for example, or we could just create a JSON file that is loaded somewhere. So by doing it that way, our test does really know nothing about the actual implementation, and we could just use this test and switch out this user can create new article precondition, and then we could use this test to test our API, for example, instead of testing our front-end code. I mean, maybe not 100%, but maybe testing the backend would not be as straightforward because there is no such concept as go to the create view, for example. But you could use the same code, for example, to test your native application. So you could use this test code exactly like it is for testing your web application or your native mobile application, for example. This is the most important idea about this decoupling. But yeah, this was the decoupling part in regards to the preconditions. And now let's talk about the domain-specific language. And you can already see it here. We have like a method that's called go to the create view. And like I said, this can work in a web application context, but you might also have a native application that also has a create view for the article. Then we prepare the user can create new article precondition. That's important that it happens after the go to step, because it would be better if it doesn't matter if we do it like if we have it up here or down here, but because we need access to the mock service worker in the window context, we have to use it after opening the page, because before opening the page we don't have any access to the window content, and so this prepare function would fail. That's, yeah, a minor inconvenience here, but it's okay. The next thing is create new. So in this domain specific language, we have this create new method, and this create new method is responsible for, in this case, filling out the form, but could be something else also in a different context, for example. And then we also have the submit method. And last but not least, we assert that the article was saved correctly. So let's put an only here and take a look at the Cypress test. So here we can see the should create new article test. Let's run it again. And we see it fills out the form and presses submit. And then, yeah, the test runs through correctly. But let's take a closer look at this domain specific language. Like, let's go to this file. And here we can see all the Cypress related logic. So, like I already said, this makes it possible to switch out basically our complete test framework. If we one day decide we don't want to use Cypress, we want to use some other tool, like we want to use Playwright directly, for example, or we want to use Jest with some other browser tool or some other web driver based tool, then we could simply go to our DSL function and change the implementation in here, and our tests don't have to change at all. We could even go a step further and also make our domain specific language completely decoupled from any concrete test framework. But I decided against it to keep it simple. If we add another abstraction layer, then the code would get a lot more complicated for not that much benefit, in my opinion at least. I mean, you have to do that if you really want to run the same code for a native application and for a web application. Then you absolutely should do it. Then you should more or less inject the driver in here. So like then you have a Cypress driver, for example, or you have I have no idea about how you test native applications, but you probably have some driver for a tool that can test native applications. You can inject it here and then use the driver. The driver then has a visit method, for example, and the Cypress driver calls Cypress visit, and the driver for your native application calls some other method that's responsible for opening some view in a native mobile application, for example. Oh, let's stick to the DSL file real quick. So we can see here the go to create view visits the create view and waits until we have some property on window. It's not really important right now. Then the create new method. Here we can see we can override our whatever is entered in the fields, but we can also leave it like it is. So if we want to test the default case, then we can just call the create new without any params. But if we want to test something specific, we could switch out, or we could pass in some other values for the body and the title. And then in here we use Cypress again to query for our data QA, selector that we saw pretty much at the beginning, and we type the title text and also the body text for the body field. Then we have the submit function that queries for the submit button and clicks it. And then we also have the assert functions, one for the success state, assert that the article is saved correctly. In this case, we simply check if there is a success message, but again, it depends on your application or what you want to test. You could even change this assert saved test to look in the database if the value really was saved. So if you have real end-to-end test, you could have implementation of assert saves that make sure that there is actually an entry, a new entry in the database, for example, would be also possible. But for this demo, I wanted to keep it simple and I only check if this success info box that we can see here, this green box, exists. And for the assert error, we check if the error info box exists. Okay, so let's go back. And in here, we can see we use the same methods for all of our tests. So for our happy path test, should create a new article, but also for the error case, should show an error message if creating a new article is not possible. Let's run this real quick. And we can see here the go to create view is the same. The prepare is a little bit different because in this case we prepare the user can not create new article precondition. But then again, that's the same. Create new is the same. Submit is the same. But now we assert that an error happens. Let's save this and this should run automatically. Perfect. And we see this test also succeeds. Okay, so let's see what's still open. This was the DSL stuff. And now, last but not least, because I find it so awesome, let's take a closer look at the live reloading feature. So first aspect of it we already saw, like if we change something in the text, and I just changed the description, we see it runs automatically again. But not only can we set up Cypress so that it runs when we change something in the test code, but we can also make it automatically run when we change something in our actual application code. So in this case, let's say I make a typo in here. So we saw I changed the code and the test immediately started running again. So the watch mode works basically like we are used to with our unit tests in Jest and view test utils, for example. Like we can change something and the test immediately runs again. And after fixing the typo, it also succeeds again. So that's really, really nice. And because there is still some time left and I planned the stream to be about 1 hour, let's do some test-driven development at the end of the stream. But first of all, I'll show you how to set it up that this live reload even works. So because out of the box, Cypress has live reloading, but only if you change test code, but not if you change your application code. But if we take a look in the package.json again, we can see here this Cypress watch and reload dependency. And this Cypress watch and reload dependency, let's check out the documentation real quick. So installation of this package is really straightforward. So you just add require plugins to your Cypress plugins file and also require support to your Cypress support file. And then you tell it what directories to watch for file changes. And in this case, let's open the Cypress JSON file. We can see I set up the Cypress watch and reload package to watch the complete source directory. So it's important that you write source and 2 stars. What I did, and I wondered why it doesn't happen, was that I wrote something like that, and then a second entry, and then a second entry for something like that. and I want that Vite doesn't live reload when I change one of my view files, but if you do it that way, then the glob pattern will only watch for files directly in the source directory, but not in nested directories. But I guess the most straightforward way is to use 2 stars, then it changes on every file change in the source directory, and I think that's reasonable. Okay, so after installing this Cypress watch and reload dependency, you get this nice live reloading when you change your application code. Can highly recommend that. Okay, so let's do some test-driven development. So for now, if you open the application real quick, there is no validation. So because it's just a simple demo application, of course, but let's write some very, very simple validation feature, and let's do it in a test-driven way. So we can open our specification file, copy some test to get started quickly, and then let's change the description. Should not allow saving incomplete data, for example. Should not allow saving incomplete data. We go to the create view. We don't need to prepare anything because we don't make a network request. If everything happens as expected, then create new, then submit, and then we assert naming is hard. What do we assert? We want to assert that the user is not able to save. Assert prevented saving incomplete. It's probably not the best name, but the best name I can come up with in a live situation on the stream. So let's go to our preconditions again, and inside of our preconditions, oh no, not to our preconditions, let's go to our domain specific language, sorry. Copy the assert method and change it to assert prevented saving incomplete. And in here we say, let's say error, say validation error title should exist. So let's say the title is mandatory and the body is not mandatory. So here we assert that saving of incomplete data is prevented. Okay. So save this real quick. Here we also have to import it in here. So, okay. So now we have our new test here again. Let's see what happens when we run it. Only is not defined. Oh, it. So, okay. Let's save again. Okay. Now we can see the test fails because we didn't implement it yet. But now we can start coding. So let's go to the app. And yeah, just to be sure, don't do this at home. I will write a very, very simple validation method, a very naive validation method. But the point is to demonstrate how nice this test-driven development workflow can be with Cypress and auto-reloading the test. Okay, so how do we do it? Probably we need, let's check again, validation error title. So let's copy it all, left, right. So we want to show it beneath our input, I guess. Let's make inline validation. Oh, I copied this. So here is some error. Okay, so and to go back to what I said earlier, so would also be probably a good idea to, like I said earlier, select by text, for example, and then you have the correct validation message in here. Yeah, it's also a valid approach, but like I said, I'm not convinced yet that it's really that much better than using data QA tags, so I stick to my good old data QA tags for selecting the test stuff, test elements, or to select the elements for testing. Okay, yeah, now if I save this, we probably succeed already. But yeah, it's obviously it's not correct. So, and yeah, we could make a negative test case. So yeah, but we don't need it right now. I mean, that's our responsibility to know that we are not done yet until this is only shown when there is really a validation error. But yeah, that's one dilemma, I think, of test-driven development, that sometimes it might be useful to test the negative case, but sometimes not. And yeah, I'm divided. So maybe we should write a negative test, like maybe we should do this. Yeah, maybe before the submit we should test assert no validation, or assert no. Yeah, or we should do it above even, because if we don't trigger it after the submit, but immediately after blurring the input field, assert no validation errors. Let's call it like that. I'm not sure about the naming stuff. Maybe this naming, or probably this naming, is not very good. Like I said before, please don't judge me for those names. I didn't think long about them. Maybe they are very. I'm very sure that they're better names, and that those are not good names. But let's do it that way for now. So certain no validation errors, and in our DSL create this one. Assert no validation errors should, I think it should not, no, it's not exist. Maybe let's try. Yeah, now this fails. Not to exist in a DOM, but it was found. Okay, so I think that's better. So now our test fails again, like it should. Now let's go to the app and make it not fail. Okay, so how do we do it? I want to validate and submit, I guess. So let's create a new validate method, validate equals method, and in here we say let's create a new validation errors object. Here we say title false, and we say body false. Oh, let's just use title, because we said we don't want to validate body. And in here we can say if title value then return, then it's valid. So like I said, that's a very naive validation method. We just check if there is any value. Obviously, if you build a real application, you want to use some validation library, but yeah, like I said, it's for demonstrating purpose only. Don't try this at home. Okay, and if there is no value, we say validation errors value title equals true, and return false. Let's call it is valid. Maybe it should be a no. I want to call it validate because it's a method. It should be called as an imperative. So if not validate, then we do nothing, and otherwise we run our code. Looks fine. Return true. Thanks, linter. And last but not least, we check in here for if equals validation errors title, I think, and we have to return it. Errors. And let's save this. And if we did everything correctly, no, we didn't. Okay, there's no, okay. There is no validation error because we actually type in the title. So our test is wrong and not our implementation. Okay, so we should get the test correct before start coding, obviously. So in this case, we say create new title body save. Typing does not work with empty string. Okay, that's interesting. So go into our DSL and let's add a check here if title if body. Okay. Okay, does not work. Our validation message is not shown. If validation errors title. Validation errors value title true. Validate, we should call it. Oh, that's a tricky one. Okay, now it works. Fine. Okay, so we saw how useful this live reloading can be, because we don't have to manually go to the browser and again and again and reload and click ourselves. All the clicking and reloading is done by Cypress, so we can focus on the coding part and occasionally check on the right how far we got in the test steps. Maybe we have, in the future, we have some more complex tests where we can solve one step at a time. So the first step would be that the validation message is shown correctly. The next step is that that some value, some calculated value is shown beneath the form, for example, anything like that. And we can really work step by step and fix all the problems in our tests. And every time we have fixed one of the problems, we can start refactoring. So we have the real test-driven development cycle, make it work, and then make the code look nice, make it beautiful. Okay, that was it for the day. So today we saw how we can decouple our tests from how we can decouple the test code from the application code, and how we can use Cypress and mock service worker to do so. And we also saw how we can use preconditions not only for the decoupling of our tests, but also as a tool for development, and how we can implement a domain-specific language. So our test code is completely decoupled from the implementation, and also how we can use live reloading and test-driven development to work on our features in a very, very efficient way with Cypress. So thank you for watching, and I hope you tune in the next time. See you.